Hi everybody, I'm Benny Olsson. I'm a software developer. I've been writing code for close to 25 years now. 25 years is a really long time. Been making a living out of it for the last 16 years. And I'm sad to say that out of those 16 years, sadly, I've only really been making conscious decisions about security for maybe the last 3 or 4 years. No coincidence in me meeting Siren 5 years ago. Absolutely not. That doesn't mean that all my code prior to those 5 years were horribly unsecure, though in hindsight they probably were. But what I rather mean is that they were secure by accident or by the fact that I followed patterns and practices that, by pure luck, made my code at least somewhat secure. So nowadays, I'm co-founder of a company called InfoStep. We're a system integration specialist company in Gothenburg, and I spend my time writing .NET code. And I've also been known to malpractice and create horrible security flaws in all of those languages as well. So that's me.
Thank you, Nimora. So, hi, I'm Fredrik. I'm a software developer. I was born in the a long time ago, we can say, and now I'm here. I've been working with coding since like early to mid 90s, we can say. And I started out when Visual Basic 3 was released. That was my first real programming experience, and then I was hooked. So I've been sort of dabbling around in Microsoft land mostly since then. And as you can tell from those bits of information, like 20 plus years Visual Basic in Microsoft land, you can also conclude that I've had ample opportunities to create some truly horrific code. And I think I've seized quite a few of those opportunities. So what's my relationship to security? Well, frighteningly much like Benny here, actually. When you were saying these things, I sort of realized that it's probably your fault. Because I've sort of been thinking security for about the last 4 or so years, and that was when I started working with Benny in a project at Click, and yeah, you see the connection. So I've not really been thinking actively a lot about security over many of those years. It wasn't really like this that I don't care because who would want to hack my code, but I just didn't think that much about it. But now recently, it's more present. And I know that you are thinking about these images here, so we just need to sort out that even though I'm way older than Benny, I obviously look a lot younger and prettier. But between Benny and me, Benny is the wizard, so the images are actually accurate in that sense. I was going to say as well that I'm old enough to have a Twitter account, which Benny obviously isn't, but he actually is because he just was a bit shy about it. So.
Okay, so we're pretty much here to tell you that we are in no way experts in the fields of software security. We do not claim to be expert. We do not claim to be any better at it than any of you are. Certainly not better than she is. But what we do have is that we have roughly 40 years of combined experience writing code, babbling with code, and doing horrible things. So we have seen and done some pretty horrific and amazing things along the way that we feel is kind of worth sharing here today. So quick hands up, everyone who's been in the IT industry for, say, 10 years or less. Oh my God, 10 years or less. I'm guessing since not a lot of hands showed up, we can do 10 years or more as well. That was a lot of... Okay, so this is somewhat irrelevant then. So 5 years or less. There's a point to all this. So 5 years or less, fine. It's 7 or 8 people. And hands up everyone who's had at least one they did what experience during that time. Close to everyone. So in our 40 years of combined experience, you can imagine that we have seen some pretty horrific things along the way. But point being, we are absolutely no experts, but we are here to share things, and we hope that you guys are going to be willing to share some things with us as well. Over to you.
Over to me. So, when we talk about security, we're talking a lot about doing things in the wrong way. And we should be aware that there are various ways of doing things in the wrong way. There are different reasons for doing stuff wrong. Lack of knowledge is one of them. I'm simply unaware that security is a thing. And if I don't even know that security is a thing, of course I will do stuff that is like wrong from a security point of view. Simply no time is another quite common reason. I know that security is a thing, I know how I should do, and then there is a deadline. So I sometimes actively need to choose not to do security the right way for deadline reasons. Was told to against better judgment. So I know security is a thing, I know how to do it, and then there is this boss coming in to tell me to do things in a certain way. So I kindly tell the boss that, well, that's not really a great idea. And the boss says back there, yeah, great, just do as I told you. And yeah, the boss has the money, so I do as I'm told. And lastly, there is this one. I know that security is a thing, I know how to do it, but I'm a lazy bastard and I just don't care. So of course I will do stupid things in my code.
So, and depending on where you work, there may be a security pony keeping a watchful eye on you as well. And you really, really don't want to blow it on the security pony's watch, because you have no idea how fast this turns into this. And when that happens, trust us, you do not want to be the one who is responsible.
I think I should be staying over here. So the talk today is roughly divided into 3 sections. We have the first section that we call You Won't Believe, where we will share some things that we have seen and come across during our years in software that maybe should not have been there. The second part is called So I Know I Should, but instead, where we will share some things that we have worked with more hands-on, maybe even things that we have created ourselves. And then there is a section called Okay, so you're on tight budget. And in that section we will share some things that you can think about, then things that you can do to add security that is not overly expensive or complicated or takes too much time. But first...
So this is going to be a somewhat interactive event. This is not just going to be us standing here talking to you guys. So we want you to all take 2 minutes, talk to the person next to you, and tell them about the worst thing that you've ever witnessed in the IT industry as far as security goes. You have 2 minutes each. Go.
Okay. I think we can take it there. Is there anybody that feels like sharing their thing that they just told the other guy? That I realize it's to stretch it a bit, but if anybody feels like sharing, this is a good opportunity. No? Okay, that's fine. That was expected, actually. You take one? Okay, thank you.
One of the portals that I was working with, we had like some bugs and we couldn't find out the problem, so we had to check the logs. So while I was checking the logs in the user, I've seen the username and password of all the users, so we logged all the passwords.
That's pretty nice.
Yeah,
Neat.
all the
Clear text user and password in the logs. That is a good one. Don't do that. Okay. Let's start with You Won't Believe thing. Tuesday, that means Patch Tuesday, Windows. This story is not so much about Patch Tuesday as such, but more patches. I had an assignment once in a company that were manufacturing small computers. And these small computers were shipped out to customers and installed, set up in customer premises. And they were pretty much autonomous data collectors. You hook them up to some measurement device, and then you hook them up to some network connection or a mobile internet thing, and then they would call in and send data. Now, the Windows version that they were installing on those machines when they were shipping them out to the customers were a pretty outdated version of Windows. It was approaching its end-of-life support date quite rapidly. So I asked the guys managing this thing there, what's your upgrade strategy? What will you do? And they said, do we need to do anything? The boss actually seriously suggested to just bulk buy huge amounts of licenses for this old Windows version while they could, so that they could continue shipping the computers with this outdated version once it's off the market. And I got a bit curious. So I had to ask them, because in this it also became clear to me that when they had shipped the computers to the customer, it was somewhat unclear who was actually responsible for the stuff in the computer, because the customer owned it, but the supplier could still sort of access the computers and do stuff in them. So I asked them who is actually like responsible for keeping them updated? Is it you or is it the customer? And the question marks around the table told me that there is no such thing happening. So these boxes with an old, outdated Windows version have probably never been patched, and they are connected to the internet. Bad thing.
All right. So case number 2 is about a product. Or rather, let's start with this. Hands up to everyone who thinks that passwords are key to keeping your data safe. No hands. I am widely impressed. Siren, you have taught them very well. So this story is about a product that I've been working with on a daily basis for the last 6 years, on and off for the last 10 years. It's a Windows application. It's locally installed on a single Windows machine. You can run it in single-user mode or multi-user mode. It does have options for security. You can set credentials, username, passwords in the multi-user mode. The password are hashed into a non-reversible value and stored in a database. You can also set access levels, so you can basically control that user A is only allowed to access feature A and B, and not the rest of it. So the application contains a lot of sensitive information. It contains companies' accounting, books, order information, customer information, sales price lists, purchase price lists, etc. Everything. In the multi-user version, you basically install it on a single machine and then install it on smaller clients on other network-connected machines. So everyone is working with the same database over local network. So, as I said, the username, the password is hashed and stored in the database. But what about database security? So, as I said, you can use it run it in multi-user mode. The database itself is an ancient database. It uses file-based tables. So every table in the database is a single file. The file is not encrypted. The content is not encrypted. It is not protected in any way. It's actually clear text. So you can fire up Notepad, drag the file into Notepad, and see the content. And if that wasn't bad enough, there are a lot of free tools available on the internet that you can use to edit the information, delete, modify the schema, and so on. To make matters even worse, there are no database server. So every instance of the application actually uses the database files directly from disk. And this raises a very interesting question. What about multi-user mode? How does that actually work? Well, it turns out the first Windows machine that you install the application on, the installer requires to be run as admin on a local Windows machine. It actually creates a shared folder on a machine. It then puts all the database files in that shared folder. And all the other clients are installed on client machines, and everyone accesses the files on that shared folder. The last thing the installer does is that it grants full access to the everyone account. Let me repeat that. It actually grants everyone full access to sensitive data that are in clear text. The product also ships with an API. It's not a very good API, but it is an API. And the API files that you need if you're a developer is also available in the same shared folder, of course. The only thing that the API requires is that you know the path to where the database files are located. So using the API, you can access all the data in that database as long as you know the path to the database folder. Using the API, you can create, update, read, and delete all the information in the database. And absolutely no authentication is required for using the API. As I said, the application itself has username and passwords, but if you use the API, there is no authentication required. No authentication is required. You all know what's coming next, so bear in mind that this is actually no small product. This is no niche product. There are roughly 120,000 companies in Sweden right now today using that software in the multi-user mode. 120,000 companies. But at least the passwords are hashed. Did I get case number 3 as well?
Yeah.
I did. Oh,
You did,
amazing.
please.
So case number 3, if you thought the database on a shared folder was bad, well, I came across a company 10 or so years ago who have a very interesting take on security in their product. The company creates a product which is an HVAC control system. So in heating, ventilation, air conditioning control system. The product consists of 2 parts. One, the actual hardware. That is the actual control system. 2, the Windows application from where you can configure it and set all the control parameters and so on. So once configured, the device is autonomous, so it can run basically forever. The device itself contains all the stored configuration and all the control parameters. So if you have a Windows laptop and you run the application, you plug it in, it will actually download the configuration and you can configure the device, and off you go. The device itself only has an RS-232 connector. So basically you fire up your laptop, you plug in your RS-232 adapter, and you start the application and you're ready to go. It does support credentials. So when you fire up the Windows application and tries to connect to the control box, you are prompted for a username and password. And this, of course, makes it kind of interesting to see how does the protocol work. So we wiretapped the protocol, and it turns out that it uses a super simple request response schema. So that Windows application sends a request, and the device sends a response back. The messages in itself is super simple as well. It has a small header and a data body. The header contains a parameter that tells what message is this, and a few other parameters as well. So back to credentials, you may assume that whenever you authenticate with the device, it generates some sort of token or session ID or something that are included in the header of all the succeeding messages. Nope. So it actually turned out that the authentication procedure sends the username and passwords to the device, and then the device only responds true or false, whether or not the username and password is correct. So that pretty much means that all the succeeding messages has no token data. It has no authentication data. It has no session ID. The device itself is absolutely stateless. So it has no information, absolutely. So as long as you know the protocol, you can just plug in and start running commands, which is great for an HVAC control system that are super frequently installed into public buildings such as schools, hospitals, medical centers, so on. Though, the devices are usually in locked rooms, so only maintenance personnel can access them physically. So this gives us at least some level of physical security. So you might say that this isn't much of a problem. But a couple of years ago, they released a new version. You have access over Ethernet. Did they change the authentication scheme or the security implementation? Nope. So unless you have a very gifted or very devoted network engineer working at the installation site, there is now a pretty good chance that the device that are controlling your heating, ventilation, air conditioning are connected to your local Ethernet, can be accessed, and it has a security that are as impenetrable to a hacker as a box of cookies for a stoner with the munchies. And you might ask how to pick up the protocol, because that's pretty key to exploiting this. Before, the Windows application has all the information on the protocol, and you fired it up and you can use that. Turns out the Windows application is freely available on the company's website. Yes.
Yeah. So, a few years ago, I was applying for speaking at a tech conference. So I went to their website, and there's this form you fill out with your speaker details, and then you add your proposed session information and data about that. And when I'm done, I click the post button, and it gets saved. And at the same time, I get an email sent to me with the URL that I can use to go back to this information and like add a session or upload a photo or edit my bio, stuff like that. A while later, this tech conference starts to post information about the upcoming conference, information about speakers and stuff. And well, curious as we are, I fire up the web browser, look at the page source, the HTML code, and I just browse through it out of curiosity. And I noticed that the URLs to the like speaker photos looks pretty much like this. And I also noted that it was quite similar to the URL that I had gotten in that mail to my edit page. It was essentially that kind of URL with some stuff added onto the back of it. So I took that stuff away, and I just tried to go there for some random speaker. And voila. I went straight into that speaker's edit form and could, if I wanted to, I mean, I'm a nice guy, so I didn't, but it was all there, all the speaker details. I could add and remove sessions. I could probably switch the speaker to be me if I wanted to. And it was wide, wide open. What we can conclude from these spicyful examples is that these things happen. They happen all the time. And they happen not only in like small anonymous homegrown projects. They happen in really, really established products all over. And with that, social interaction amongst nerds too. So now, take the same pairs as before, 2 minutes each, and discuss what's the dirtiest you have ever felt when you've done stuff in code.
Roughly an hour and a half.
Not when, what?
All right.
Får ta i lite.
So, moving on. As we enter the I know I should have, but this story falls under the label lack of knowledge. So we're going to do some hand raising again. Hopefully not too many hands are going to be raised. So hands up everyone who has concatenated the SQL strings with user input. Hands up everyone who has used the SE or root account for access to a database in a production system. Hands up everyone as required to their application or web application to run as admin on the server. Surprisingly few. And hands up everyone who has bypassed security by running your code with elevated privileges. Oh, I'm pretty alone here. Hands up everyone who has done all of the above in a single project. I'm gonna make you sad. So this story goes back to the early 2000s. So has any one of you ever played OWASP Top 10 Bingo? For those of you who doesn't know what it is, it actually means that you look at a project and you tick off the points on the OWASP Top 10 issue list that is applicable to that project. The project I'm gonna tell you about hits all the issues. I know you are. So this goes back to the early 2000s, and this was my first gig as a professional developer. I worked at a company who were building intranets. Everyone was building intranets back then. So the part of the project that I ended up working with was an Exchange integration. So we had a order to enable our customers to work. You use their email and calendars, Exchange mail and calendars from the internet, so that the users wouldn't have to log on to the absolutely horrible Outlook web application client that existed back then. It is still horrible. So basically, they wanted every user to be able to have full access rights to their mail and calendar from the intranet site. Now, Exchange back then actually had an API that was pretty easy to work with. And to just give a brief overview on the stack that we were using, this was an ASP 3.0 web application running on IIS 5, I think.
I wasn't there.
No, I know you weren't, but like 2000 must have been 4.5 or 5. And so we didn't want the ASP3 code to talk directly to the Exchange API, so we wrote a COM+ component in VB6. Because why not? Yeah, I know. So the ASP3 code talked to the COM+ component to then talk to the Exchange API. And the only way to actually access all of the data through that COM+ component that we knew of at the time was to use the Exchange super admin account who had access to all of the users' email and calendar. And since the intranet itself didn't use NTLM-based authentication, it used a simple username, password, stored in database, clear text, by the way. A scheme. We didn't have a Windows context with us in the invoke, so we had to use the Exchange super admin user that could access all of the information. And since we didn't knew how to use impersonation in VB6, I don't know if it even should have been used. We more or less set that the IIS user, the context under which IIS was running, was the Exchange super admin account. To make matters even worse, so this basically meant that every call coming in on the ASP3 site could access all of the users' calendars and email, not only read it, but delete and create emails and create calendar appointments as well. To make matters even worse, it gets worse, trust me. To make matters even worse, we of course used string concatenation for the authentication page as well. So a simple web form HTTP, not HTTPS, that was kind of fancy. HTTP web form username, password, clear text to the server, concatenated string, sent back, are you logged in or are you not logged in, and what session that was connected to. So basically by exploiting the SQL injection, you could read all of the users' emails, create calendar appointments, whatever. Plus all of the database access was used using an SA account as well. So yes, we ticked up every box in the OWASP list with that project.
I have one. Oh, that one. He wins. So yeah, we continue on the lack of knowledge path. This is also an old project around that era, even earlier actually. I created a community site. People did that back then. So I created a photo community. I was building and running that for a few years in the late 90s. Of course, HTTPS, as you said, was pretty fancy. I think back then I was vaguely aware that there was such a thing called HTTPS, but I probably had no idea what it was good for. And I certainly didn't use it. This website was also a pretty clear plain text offender. Everything in the database, which by the way was a Microsoft Access database, was in plain text. Usernames, passwords, the whole thing, and also no HTTP. And it was public internet, so of course you could just listen to it anywhere and pick up information. And also, of course, why not? SQL, everything was concatenated strings in classic ASP, so it was probably just a wide open hole waiting to be exploited. I think I went through the OWASP list, and I think on that project, as far as I could remember, I hit about 50% of the things that it could do on that list.
Win.
You win. But I still was really proud of this thing, actually. I was really proud of it at the time. Maybe not so much today. And if you continue down the same road, and I mean that was a project that we were talking like late 90s, it was a hobby project. I was sitting at nights and weekends and doing this stuff. So it's sort of maybe forgivable. But this project here is quite the opposite. It's a big corporate project, and it's a bit later, and it was commercial, and we worked on it for a couple of years, so it was a big thing. Of course, if you combine these words here, we have HTTP access, no HTTPS. We toss in a file upload component, in which we upload Excel files that we give to a third-party component with unknown code to load those Office files and do stuff with them. During this project, I think we worked two years with it. I think that the word security may have been mentioned a total of 0 times during that project. Now, we didn't experience any security issues with it, but I'm quite sure that a penetration tester would have a field day playing around with it. It's probably just a portal to Pandora's box or something. On the upside, this was an internal project. It was running on their internal network, at least then. Because as we all know, these things, that parameter tends to sometimes change over time. That no worries, it's just an internal tool, and then suddenly it's not. So with that, we move on to
My next sin.
your next scene.
This, by the way, is the entire evening. For any one of you who was hoping for some sort of profound insight or glorious experience, no. You. This is just us admitting our old sins, and you are currently our own private therapy group. And speaking of commercial applications, we successfully shipped the product that I was talking about, and it was commercially available up until 2005. So my next big sin is actually the next product that I landed in. Totally different company, but I was hired to do the exact same thing once again. I was the mastermind behind the whole hideous Exchange integration thing. So another company wanted the exact same integration again. So I was very, very clear with the hiring manager that you should not do this. This should not be done this way. Because by then I had realized that, hey, I fucked up. Had there been an evil pony looking at me, I would have deserved it big time. So I was very clear with the manager that you should not build this. Put it straight. This should not be built. But to no avail. I ended up having to build the exact same thing again because even a developer needs to pay his rent. Which also brings us to simply no time. And I don't know why there's an overweight on my end here in this part of the presentation. I have more sins. So simply no time. I work a lot with ERP systems in very, very small projects. And normally when a consultant says a small project, you're thinking like, hey, 3 months. I'm saying 3 to 5 days. So I'm usually stuck in very, very small projects. And those small projects usually entail to define the application, write the application, deliver the application, and fix a couple of bugs along the way as well. So you have to do trade-offs all the time. And security tends to be one of the few things that are traded away first. Because it's hard to tell a customer that, hey, we want you to pay 8 more hours. We want you to basically add 20% more to your budget just because of some security measure, which they don't understand and they don't want it. And they're like, hey, just publish it. So I usually end up writing a lot of custom reporting tools for ERP systems. And a lot of those tools read data straight from the SQL database that the ERP system are using. And due to time constraints, we usually end up having to enable every Windows user who are going to use the reporting tool to have full read access to the entire database and all the other databases stored on the same server. Mostly due to ERP API design, but again, simply no time to fix it. It's one of my big, dark, current secrets. And on the topic of simply don't care, this, of course, does not relate to anything that I did. But again, wait, what? Good save. I'm blaming a colleague here. He did it. So again, back in the days, 2002, I think, different company, we were building intranet sites again. This intranet site had groups, much like Facebook groups work today. So you could set up groups, you could invite people, and you could have discussions in that group. One of the features that we had was also that you could send text messages to everyone in the group, text messages, SMS messages. So we used an HTTP-based SMS gateway, not HTTPS, because that actually wasn't available. And a colleague of mine, again, I'm blaming the colleague here. Please keep that in mind, especially since this is going to be published. So my colleague implemented the send method in JavaScript because it was a HTTP-based SMS gateway. Why not use XML HTTP request? So he implemented the entire send method in JavaScript, meaning that if you took a look at the JavaScript code, you could see the URL to the SMS gateway in clear text, the company's username and password for that SMS gateway in clear text, the parameters for receiving phone number and text message in clear text. So basically, he gave everyone who was using that intranet site a way of freely sending text messages to everyone they know without any consequences. So we actually talked to him about it, and he just shrugged and didn't care because he wasn't footing the bill. And the customer wanted their text messages sent.
Where are we on pizza?
I was about to say, pizza should be
They're in
here.
progress.
They're in progress.
Yeah.
So the question
Right.
is if we should take a pause here, or if we should do that.
We can do the next.
We can do the next and then
slide.
we pause. Yeah.
Is that yours or mine?
You can take it.
I can take it.
Yeah.
Okay. So we have another social interaction among nerds part. What is your passion in work in IT? What is your driving force? What is it that you're looking forward to at work when you wake up in the morning? And obviously, we can take more than 2 minutes if you want to, since pizza is going to be here in a minute. But think about it and talk to each other about it. Pair up like you did before. What is your driving factor? What is your passion?
So let's continue with security in the wild from the developer's point of view. So we've been sharing some stories, some things we have seen, some things we have done. And at this point, things may seem a bit depressing. A bit. People lack necessary skills. Time is tight. Bosses are mean and make you do stupid things. But we are here to tell you tonight that all is not lost. There is hope and things you can do. Security is a thing that should come here. Security first. The thing is that it doesn't have to be expensive. It doesn't have to take huge amounts of time, and it doesn't need to be complicated. And putting it in the beginning of the project is key to achieving those things. So to work proactively with it. Bring it in early, do some simple threat analysis and threat modeling. Are you going to talk about that later? Yes, good. Listen to her.
I have a question. Is it like I work as a tester, and we always say that we want to come in early in the beginning of the features. But is it something that you can combine, like when you talk about tests, and you can perhaps combine it with security as well to bring up the security aspects of it?
So the question is for the camera, that as a tester, you also talk about a lot that you want to come in early in the process to bring up testing as well. And I would say that those two marry very well because security is a thing that should be tested, of course. So when you start to look into security and which ways your software might be threatened, you also, of course, want to know how can I test this to verify that we are not open to such threats. So I think one of those does not exclude the other, rather quite the opposite. I don't know if that is an answer, Jim. Yeah.
I think as Sarah will probably say later on, is that the output of a threat modeling session and a threat analysis session is data that you can use as a tester when a feature has been delivered by the developers.
That's exactly what.
Cool.
Yeah, I've learned.
Yeah, so bring it in early, work proactively, do some threat analysis, threat modeling, to try to find out in which way your product might be threatened when you start to build it. The thing is that regardless of what security measures you do make, they will always be more expensive to do later, to add afterwards. Now, if you do have, we have talked some about this time thing. We are short of time, so it could be that you have a deadline. You really, really sit there and you need to choose. You can't do everything you want to do. So let's say that you need to choose between putting in some time now to do some proactive security work, or we can do some security testing in the end. If you have that choice, proactive work is the way to go. Because if you do that and you probably find some basic and obvious security mistakes that you might do, and you might avoid those threats. If you don't do that, but instead test in the end, I can almost guarantee that you will find those obvious threats, but then you have no budget to fix them. And so with you.
Right.
Your favorite subject.
Documentation. So before the pause, we talked about that you guys were going to talk to each other about what is your passion at work. Hands up, everyone who said documentation. one person. Case in point. So I'm a developer. I am lazy. I will go to any extent imaginable to avoid having to do documentation. I even started my own company and made up fancy titles to be able to avoid doing documentation and being able to push that to someone else. So I can come up with 100 reasons to why I should not write documentation. But the simple truth is that it's boring. I don't like to document things. It's boring. It takes too much of my valuable time. But fact of the matter is that the cheapest and easiest way to do proactive security work, apart from threat analysis and threat modeling, is to document what you've built. So we're not talking about some super fancy documentation here or code documentation. If you just document your data flow, your overall architecture, write down your general thoughts about the problem, that is going to be worth a lot later on. So in 12 months time, when you revisit the code or you find some weird security issue, you remember this guy? Well, all that gray hair didn't come from nothing. I learned my lesson for when it comes to revisiting code. Also, when you do the documentation, try and brainstorm and come up with a couple of... It doesn't like me.
That's Mikkel's cue.
Try and brainstorm and come up with a couple of what-if scenarios. What-if scenarios based on the threat modeling that you, of course, did in the previous step. Try and come up with what-if scenarios and come up with an action plan for each of those scenarios as well, so that when things happen because you were in a tight budget or the boss forced you to do bad things in the code, you can always go back to that documentation and say, hey, here's the scenario we thought of. Here's the action plan we thought of when we were not in a constant state of panic. So documentation, really.
And so let's say that we are now sitting and implementing things in our code. One other thing that we can do that is really not very complicated and not very expensive, but quite important, is, I thought, this. Can you read that? I don't know, it doesn't show very well. It says encrypt. Encrypt. So yeah, any data traffic should be encrypted, regardless of whether it's going on the public internet or if it's going on your internal network. It should always be encrypted. And it's really, really not that hard. If you are talking HTTP, which a lot of communication today is using, setting up SSL with a certificate, it's not super complicated. An SSL certificate doesn't cost a lot, actually. It's free even, maybe. There is really no reason not to. And if you have an attacker that wants to listen to your code, doing this one thing will make it so much harder. We were talking about, you said that there are free SSL certificates. I'm not read up enough on it, so the figure I had was approximately the same as having a consultant working for 2 or 3 hours to write some fancy encryption code for you, and that will not buy you a lot of security. So encrypt your stuff. And on that matter...
Yeah, so you guys can pretty much think of this as a short lessons learned thing from our point of view. And one of the most important things that I've learned, at least, is don't roll your own. It is super exciting, very, very fun to write encryption code. It is absolutely an amazing amount of fun to write advanced algorithms. But in production environments, especially when you're on a tight budget, do not roll your own. And this goes. So just for the camera's sake, I'm going to shorten that down. A general problem with open source libraries, especially the encryption ones, is that the developers writing that are the 3 guys who actually are good at the math behind it, not necessarily good craftsmanship as far as development goes. So they contain bugs that ordinary developers would catch, but they aren't catching it since they're afraid to touch the code, since they're been taught to not roll their own. And I agree, absolutely. That is a problem. But given the average developer, I would still say that it's much safer to use standard libraries than rolling your own. Had we had more time, we have some excellent examples of this in live production projects as well. But again, try not to roll your own. If you do need encryption, don't write it. Use a standard library. If you're a .NET developer, there are things in the .NET library for that. If you're a Java developer, there are things in the Java framework for that, and so on. If you need authentication, if you need whatever, you all get the point. This also applies to testing. Unless you're rolling some truly exotic stuff in your product, there's definitely already a project online that you can use to do more or less automated security testing of your application and of your product. Burp Suite, for example, which I'm sure Saren will mention.
Don't do all of our talk now.
So just to reiterate, common reasons for doing it wrong. We have lack of knowledge, which you all heard. And lack of knowledge is something that we can fix. We, as developers, as testers, as architects, we can learn from our mistakes, which we've told you guys about our mistakes, and hopefully you can see that we have learned something. I do hope that all of you also learn from your mistakes. So lack of knowledge is something that we, as developers and testers and tech people, can fix. Was told to, harder to fix, but hopefully this talk has given you some ideas of what you can do to basically do security measures under the radar. Simply No Time falls under the same category. Hopefully, you guys are going to take something away from this that can help you in time-constrained projects. The just don't care issue, I'm just going to leave it at that.
That's a hard one.
Not here.
They're probably not here, exactly.
Absolutely not.
Exactly. So in contrast to the 4 ways of that things can go wrong with, we have some ways of doing it right instead, of course. As we have mentioned here, proactive security, to put in security thinking early in the project will help you a lot. Spend at least a little time thinking about it before you start building stuff. Documentation, as Benny was talking about, document your boundaries, document your data flows, your interactions, and you can use that later to see where you might experience problems. Encryption, encrypt traffic. It's not very hard to do. It's not very expensive to do. Just do it. And the last point there, don't roll your own. Use what it's already done, because they probably did a better job than you can do, at least than I can do. And this one should be pretty easy, because it's actually about not doing stuff. So, yeah.
So again, if you actually do any of these, we all want to keep the super upset security pony off our backs. We don't want that sneaking up on you. So whenever you feel that you are about to do something stupid, think about this one. This one is nagging in your neck every time you do something bad. So use our lessons learned. Hopefully you guys can take something away from it and use in your next project. Because if you do this, you keep your pony off your back, you can turn this into this. And you definitely want to do that. You do not want angry pony, you want happy pony. And with that, we say thank you.
Thank you. Bra.